Okay, so welcome to this session. In this particular session, we are going to study about trigonometric functions of any angle. What is meant by any angle? Now, we are not going to talk about the angles which are not standard angles. For example, let's say sine of 40 or so. But we can still find out the basic information about that too in this particular lecture. But again, what about, let's say, sine of 180 degrees or cos of 270 degrees or sine of 120 degrees? In your school days, you were particularly concerned about only the acute angles and find the trigonometric ratios about it. But in this session, I will introduce you to the next concepts. So let us understand this using a standard unit circle. Okay, so in this case, this is standard circle and unit circle. Why it is standard? Standard because its center is at origin. So it is like x-axis and y-axis are axis for this particular circle, and unit because its radius is equal to 1. Okay, so in this circle, let's take this angle theta. Okay, and let's say this is the point P whose coordinates are x and y. Okay, now if I take the coordinates of this particular point P, okay, as x and y, okay, and let's say, then what we know is this x coordinate is nothing but the distance from y-axis, right? So distance of this point from y-axis is x coordinate, so this is x, and the distance from x-axis is y coordinate, so here we have y. And OP is going to be, right, so as we know, so OP is equal to 1 because it is radius of the unit circle. Then we have OM is x and PM is equal to y. Here sine theta is equal to what? Sine theta is equal to opposite side, which is y, divided by hypotenuse 1, so y by 1. And what is cos theta? Cos theta is equal to adjacent side x divided by 1. So in this triangle, what we have, x is equal to cos theta and y is equal to sine theta. So on this unit circle, if I take any line starting from origin to any point on the circle, if I connect this line and this is making angle theta, then coordinates of this point, which is the, right, if this is the angle theta, then coordinates of this point, they are going to be cos theta and sine theta, right? And that is going to be useful for us to study trigonometric ratios in simpler manner and solve the problems efficiently. So on unit circle, we can find sine and cosine by measuring ordinate and abscissa, that is y coordinate and x coordinate respectively. I hope you understood this. If not, just again go through this particular portion and think about it. Now, trigonometric functions of any angle, we will continue with this. Now let us try to find sine and cosine of quadrantal angles. What are quadrantal angles? Which are a multiple of 90 degrees, right? Okay. So as we know, this point, as I have shown the circle, the point A, its coordinate will be 1, 0 because we are talking about the unit circle, right? So this point will be 1, 0. What will be the coordinates of this point B? It will be 0, 1. Then the coordinates of this point C will be minus 1, 0 and point D will be 0, minus 1. So let's talk about for 0. From this triangle, we can see that this, for this angle, for this A, right? Okay. If we take the 0 degree angle, then the line will be here, right? And this coordinate should be cos 0. So cos 0 is 1 and sine 0 is 0. So I can write that. Okay. So our diagram is quite explanatory. For 0 degree angle, sine 0 is 0 and cos 0 is 1. Now let's move to the 90 degrees. So where is this 90 degree? Here. So these coordinates of point B should be cos 90, sine 90. So cos 90 is 0 and sine 90 is 1. Let's write it down in the table. So I have written for a 90 degree angle, cos of 90 is 1 and sine of 90 is 0. Okay, you already knew this, right? Let's go further now for 180 degrees. So as this is 180 degrees, this is the line which is making 180 degrees. So coordinates of this point should be cos 180 and sine 180. So what is sine 180? Sine 180 is 0. And what is cos 180? So here sine 180 is 0 and cos 180 is minus 1. So we have written in our table, right? So for 180 degrees, sine 180 is 0 and cos 180 is minus 1. Let's move further for 270 degrees. So this is the line for 270 degrees, right? This OD. So this coordinate should be equal to cos 270 sine 270. So this is cos 270 0 and sine 270 minus 1. 360 degrees. So 360 degrees, we are again coming back to 0, right? That's why it is again for 0. So for 360 degrees we have 0 and 1, right? And it can be repeated. 450 degrees, 450 degrees means 360 plus 90, right? So where we are at B. So it is equal to whatever the ratios are for 90 degrees. So for 450 degrees we have sine is equal to 0 and cos is equal to 1. What about minus 90? So by minus 90 we again mean 270 degrees, right? So cos of minus 90 is minus cos of, right? So cos of minus 90 is equal to 0 and sine of minus 90 is equal to minus 1. Okay. So for quadrantal angles, you can easily find out the sine and cosines. Just try to understand this diagram and use it wisely. So here we will try to generalize this. Sine of n pi is equal to 0 for n belonging to z. Do you understand how? Because for 0, then pi, matlab 180 degrees, then 362 pi, then again. So if we go on like for angles pi, 2 pi, 3 pi, so sine is going to be 0 because as you can see, the y coordinates are 0 at A and C both. Similarly, cos 2n pi, 2n minus 1 pi by 2. So cos of 2n minus 1 pi by 2. This is odd multiple of pi by 2. So odd multiple of pi by 2, this is 1 into pi by 2. Then this is 3 into pi by 2. Okay. So if we take 1 into pi by 2, we are at B. If we take 3 into pi by 2, we are at D. Then if we take 5 into pi by 2, then we are again at B. So at these 2 points, as you can see, the x coordinate is 0 and that's why cos is going to be 0. So cos of odd multiple of pi by 2 is always equal to 0. Right? Then cos of 2n pi is equal to 1. Okay. So, okay, let's go further. So cos of 2n pi is equal to 1. So at this particular point, 2n pi, that is n into twice pi. What is twice pi? 360 degrees. So if we take for 0 or again after 360 or again after 2 rounds, that is 270, we are going to get the value of cos to be 1. Cos of 2n minus 1 pi, that is odd multiples of pi. That means 1 pi, we will be at C, 3 pi, 1, 2, 3, right? So after 3 pi, we will be at C and we have the cos of 2n minus 1 pi is equal to minus 1 for n belonging to Z. Similarly, we can have this formula for sine also. Here I'm writing this. So sine of 2n pi plus pi by 2 is equal to 1. That means one complete rotation. Okay, what we have here, one complete rotation. Okay, one complete rotation plus pi by 2 or 2 complete rotations plus pi by 2. How many rotations you do plus pi by 2? Obviously, we are going to be at B and sine of that value is going to be 1. And then sine of 2n pi minus pi by 2. That means one complete rotation minus pi by 2. So we will be at this 270 degrees and that sine value will be equal to minus 1. Okay. Now these are very crucial formulas You need to understand this and also remember this, and we will use these formulas during our further calculations also. I hope you are writing it down, noting it down. Okay, so remember these formulas. Now, sign of trigonometric ratios. So, as we have already seen, for a point P making angle theta at origin, abscissa means x coordinate, that is equal to cos theta, and ordinate, which means y coordinate, it is equal to sin theta. So, in first quadrant, on Cartesian plane, x and y both are positive, that means sin theta and cos theta is going to be positive, right? So, for an angle which lies in the first quadrant, which can be, let's say, as we know, right, this is 0, this is 90 degrees or pi by 2, this is 180 degrees, this is 270, obviously it is minus 90 also, this is 360 again, this is 450. So if we are talking about the angle which is between 0 to 90 degrees or from 360 to 450 degrees, we know that these angles are going to lie in the first quadrant, and for the angle which lies in the first quadrant, cos and sin both are going to be positive. So if someone asks me, let's say, what is the sine of cos of 400 degrees? We know it is positive. Why? Because 400 degrees is between 360 and 450. That means it is going to lie in the first quadrant, and as we know, in the first quadrant, cos and sin both are positive. What will happen in the second quadrant? In second quadrant, x coordinate is negative. So x, we have negative side of this x is negative and y is positive. That means cos is negative and sin is positive. So if our angle lies between 90 degrees to 180 degrees or 450 degrees to 540 degrees, then we know that our angle is in second quadrant, right? And then from that we can say that the cos is negative, sin is positive, hence tan is negative, right? Negative upon like positive divided by negative is negative, so tan is negative. Then as cos is negative, its reciprocal sec is negative. So what is positive? Only sin and cosec are positive. As sin is positive, its reciprocal cosec is also going to be positive. See, whenever we have some angle and we need to find out the sign, okay, whether it is like sign of that angle is positive or negative or cos of that angle. So first of all, locate the quadrant, okay? You know how to count the angle, how to measure the angle, use that and determine the quadrant and then use these facts. Now in the third quadrant, we have minus, as we know, in this quadrant, the x coordinate is negative and y coordinate is negative, right? Minus, comma, minus. So both of these are minus, and that's why cos is negative and sin is negative. As cos is negative and sin is negative, it's reciprocal. Reciprocal of cos is sec, and it is negative. Reciprocal of sin is cosec, and it is also negative. But tan and cot are positive, right? As sin and cos both are negatives. So in the third quadrant, that is when angle is between 180 degrees to 270 degrees, and other cycles we have. Now for that, sin and cos will be negative. And in the fourth quadrant, we have plus and minus. So x coordinate is plus and y coordinate is minus. So here x coordinate, that is cos, is positive, and y coordinate, sin, it is negative. Okay, so here cos and sec are positive and all other ratios are negative. So in this way, by determining the quadrants, right, we can tell by knowing the angle, we can tell whether which ratios will be positive and which ratios will be negative, and we can do vice versa. Now remember this: in first quadrant all positive, in second quadrant sin and cosec positive, in third quadrant tan and cot positive, and in fourth quadrant cos and sec positive. Okay, this is the sufficient information. Now let's try to solve this example. If cos theta is negative less than 0 and cot theta is positive greater than 0, determine the quadrant in which theta lies. Answer. Now cos theta is negative. Now cot theta is equal to cos theta upon sin theta, and we have cos theta upon sin theta is positive, but cos theta is negative, so sin theta should be negative, right? Because ratio of the two numbers is positive, but one of them is negative, then other has to be negative, right? And now as cos and sin both are negatives, minus minus, so this belongs to the third quadrant, right? You are correct. So it belongs to third quadrant. Let's solve one more example. Evaluate cos square pi plus sine square pi by 6 plus sine cube of 3 pi upon 2. Okay, so you have to remember what is the value of cos pi, right? We know cos pi means cos of 180 degrees is minus 1. Do you remember this from the diagram of the unit circle? Try to do that. That is going to be useful. Okay, how? So try to make a quick diagram. So we have this circle. Where is 180 degrees? Here. What is this coordinate? This coordinate is minus 1, 0, right? Minus 1. Okay, let me write it properly. So this coordinates, right? It is minus 1 and 0. So you know x coordinate is cos. So cos of 180 is minus 1, right? It's very easy. Okay. Now sine of 3 pi by 2. 270 degrees. Where is 270 degrees? Okay, we have the location, and sine means y coordinate, it is minus 1, and sine of pi by 6, that is sine 30 degree half, you already know. Put all the values, right? So minus 1 square plus half square plus minus 1 cube, and which is 1 plus 1 by 4 minus 1, and the answer is 1 by 4, right? You can solve many problems involving what we have learned till now. There is a lot to learn, and there are many problems to be solved. I hope this is, we will study the next portion in the next video. Thank you.